Video lesson 9.7, angle of elevation and depression. So when dealing with these trig functions, specifically in word problems, a lot of times we get two pieces of terminology that we see often that we want to make sure that we clarify. And that is, our first one is angle of elevation. And our second one here is angle of depression. So the first way to think about this is, if you look at this first example here, angle x here, it's an increasing angle measure. So it's coming from the ground up. So that would be our angle of elevation is referred to as a measure that's going from the ground up and an upward angle. So it's always coming off a horizontal plane though, as you can see here. And the other thing is you notice it's inside the triangle. That's important. Angle depression is, again, if I have some type of horizontal plane, so in this case this horizontal line right here, the angle that is produced going downwards is your angle of depression. So it's a downward angle from a horizontal line or plane. Notice it is outside of the triangle. All right, that's very important because right now, if I had this angle of depression, I couldn't actually solve this equation. This situation. I'd have to utilize that angle of depression to find the information that's inside there. But we'll get into that a little bit later on. The other way I like to think about this, and I just personally think it makes a little bit more sense and is easier to envision, is how you think about it from your own perspective. So I think it helps if you think of it from line of sight. So if person A here, if they look straight out in front of them here, right? And they look at person B without moving their head. If they just took their eyes, lowered their eyes to person B, they would then be looking this direction. That angle that their eyes just made, that's your angle of depression. And you can do that right now. If you stare straight out right in front of you, right? Look at the screen, right? Now without moving your head, look at the keyboard, right? If you all of a sudden you just dropped your eyes, right? You had a horizontal line straight out in front of you, and then when you dropped your eyes, you just made an angle of depression, right? So from person B's perspective, their line of sight would be here, right? If they look up to person A, then they may now they're looking this way. That they just created an angle of elevation, right? So when we're thinking about this, right, we can say here that the angle of elevation is looking, in this case, looking up. And from the description of this scenario, angle of depression would be looking down. I just think it's a little easier to kind of interpret or think about it. And if you're ever stuck, you just, in a scenario or a test or a thought, just look straight out in front of you. If your eyes go down, your angle of depression. If your eyes go up, angle of elevation. All right. But notice something that had just happened in this situation when we just did this. The observers, right, with respect to each other, what do you notice about their angle of elevation and their action? Well, hopefully, if you can think back to earlier in the year, we had this Z-like shape here, which means we have alternate interior angles. So alternate interior angles, which means that the angles are congruent. So we can say that the angle of elevation is always going to be congruent to the angle of depression because the line of sight acts as a transversal, creating alternate interior angles. All right, so let's utilize this here to solve some word problems here. So in this first example, the picture is drawn, but they tell us that we have an angle of elevation from the ground to the top of the tree. So here's my hair. So this is my angle of elevation. So from the ground to this dotted line, that's my angle of elevation. So they're telling us here that at the point is 20 feet from the base of the tree. So from this point to the base of the tree, that's 20 feet. All right, for that part. And we are looking for what the height of the tree is. What is the height? So that is here. So it's going to be my x. So when trying to do this, now I have a right triangle. I know that this is a right triangle because we're dealing with a height, right? Which means that that has to be a perpendicular to the ground. So we have ourselves a right triangle here. So now I can use Sohcahtoa, right, to help me be able to identify which trig function to use to solve this. So again, as always, I recommend inside the triangle labeling your opposite, adjacent, and hypotenuse sides. So across from the angle is your opposite, across from the right angle is your hypotenuse, and that makes the other one adjacent. So in this scenario, I've got the opposite side that I'm looking for, and I have the adjacent side. So out of these three, opposite and adjacent, so O and A, that gives me the trig function. So now I can say tangent of the angle, which in this case is 34, equals the opposite side, which is x, over the adjacent side, which is 20. Once I have it, I can put this over 1, cross multiply. All right, x is going to equal 20 times the tangent of 34. So let's plug that into the calculator. So 20 tangent of 34. That's going to give us this decimal number. So x is going to equal 13.4901. So the question says here to the nearest tenth of a foot. So that gives us the tree is approximately 13.5 feet. Let's look at example number 2 here. So we have a tree casts a shadow that's 20 feet long. So I got to go plug that into my diagram, but I notice I don't have a diagram. So that sometimes makes these a little trickier. So I'm just going to sketch. Doesn't have to be perfect. Just going to set the situation. So I got a tree. It's casting a shadow that's 20 feet long. So this is 20 feet. All right. It says then it has an angle of elevation from the end of the shadow to the top of the tree. So I'm going from the end of the shadow to the top of the tree. And it's an increasing angle measure of 66 degrees. So therefore, I now have the angle of elevation, and they're looking for the height. So I'm looking for how tall is this, right? So that's my right angle there. So my x is going to be the tree's height. I have this one here. So now, again, in order to decipher and which trig function to use, I'm going to think Sohcahtoa. I'm going to say opposite the angle, across from the hypotenuse, third side is adjacent. So again, I have opposite and adjacent, so I'm going to use the tangent function again. So tangent of 66 is equal to the opposite side, which is x, over the adjacent side, which is 20. Again, put this over 1. I can then cross multiply. So x equals 20 times the tangent of 66. So we can plug that into our calculator. We get here 20 tangent of 66. That gives us this decimal answer, 44.9207. So x is going to equal 44.9207. And they asked us to find the height of the tree to the nearest foot. So that means the tree is approximately 45 feet tall. All right, so again, you just got to be careful. You want to make sure that you're paying attention to the terminology. and dealing with the nuances of the actual problem. Again, drawing yourself a diagram is to me key, especially when they don't have anything. But if they do give you one, like they do in number 3, make sure you label it accordingly. So from the top of the fire tower to the forest ranger who's on the ground is an angle of depression of 40. So we got an angle of depression here, all right, which is going to be that 40 degrees. So that's this part here. The tower is 45 feet tall. All right, so that's, and they already labeled that. So this is 45 feet tall. And it wants to know how far is the partner from the base of the tower. So we're looking for the forest ranger's distance here from the tower to him. So with respect to the angle, I want to figure out the sides. Well, that angle is not inside of here, so I can't use it as an angle in the triangle, so I can't determine the respectively which side's opposite, adjacent, hypotenuse now. So there. So for the angle of depression, though, we can utilize our alternate interior angles. Right? So if this is 40, that means this one's also 40. So now I can say with respect to this angle here, this is my opposite side. Across from the 90 is my hypotenuse. Third side's adjacent. So now I can say, okay, using Sohcahtoa, which one do I want to use? This one also happens to be tangent, opposite, and adjacent. So tangent of 40 is now going to equal 45 over x. When we go to solve this one, though, cross multiply and solve, right? X first, you get x times the tangent of 40 is equal to 45. So x is not alone, so I do have an extra step. I got to divide by tangent of 40 to both sides. That will get my x to be alone. So x is equal to 45 divided by tangent of 40. So let's plug that into the calculator here. So we've got 40 divided by tangent of, 45, sorry. 45 divided by tangent of 40. And that gives us 53.6289. So let's plug that in here. So x equals 53.6289. And let's make sure we answer the question. It says the distance to the nearest tenth of a foot. So the ranger is approximately 53.6 feet away. All right. So again, a little bit different process because we had to do a little extra work to figure out the angle relationship, but that is the concept. All right, last but not least, here we've got a situation here where we've got a ramp to some type of platform. It tells me that it's 4.5 feet from the ground, so that's this part here. All right, the ramp itself is 11.75 feet, which is this piece, from the ground to the top of there. So determine the state to the nearest degree, the angle of elevation that the ramp has. So now here is an example where we don't have the angle. We're looking for the angle. We want to look at the angle. The angle of elevation is an increasing angle from the ramp to the ground. So here's the ground, here's the ramp, there's my angle. So I'm looking for this. Now you can call it X, you can call it theta, you can call it, whatever letter you want to use, but just from there, I'm going to use theta because that's kind of like the norm. But again, if you'd rather use X, by all means use X. So let's figure this out in here. So now, with respect to that angle, I'm going to use that to help me determine my Sohcahtoa. So opposite, this would be across from the 90 is hypotenuse. The third side is adjacent. So I have opposite and hypotenuse. So that means that I'm going to be using sine. So now let's set it up. So sine of my angle, which I'm calling theta, equals opposite, which is 4.5, over hypotenuse, which is 11.75. Again, when trying to solve the angle measure, I can't plug this into my calculator with just sine of something. I don't have a number there. So I got to use the inverse function. So let's rewrite this. So we're going to say theta equals the inverse, that's sine with a little -1, of the fraction. So 4.5 over 11.75. Now I can go in my calculator and plug this in and see what kind of a number we get for this one here. So let's take the calculator and plug them in. So that's going to give us here second sine of the fraction 4.5 over 11.75. That gives us 22.5183. Let's go back here. So we've got 22.5183. And let's make sure we round accordingly. What did it ask us to round to? Nearest degree. So now I'm looking for that is, so the ramp makes approximate angle of 23 degrees with the ground. There. All right. So again, that was a nice one because we were different. You know, I was looking for the angle measure. We had to go back to thinking about our inverse trig functions. But again, it's a good one. It's something that you can see on often on types of exams. So it's one you definitely want to make sure you understand and could be able to do as well. All right, so take opportunity. Again, re-watch any of the video that you might have had a little bit of difficulty understanding. And don't forget to utilize the practice problems for better understanding.